What's up, guys? So in the last few years or so, we've seen this explosion of premium Mini ITX chassis targeted at better airflow, liquid cooling support, and hardware compatibility. This new breed of small form factor cases has more or less been well received by the community, allowing for an assortment of powerful configurations never before possible in such a tiny footprint. One caveat, however, is that many of these chassis are designed with the close proximity between the power supply and graphics card, which is often said to pose a thermal concern, particularly for cards whose fans are either partially or entirely blocked by the PSU, thereby restricting the amount of air intake required to keep the GPU cool. A popular school of thought to combat this potential issue is to use a video card with a single blower-style fan that's positioned at the far end of the cooler and thus uneclipsed by the power supply. Additionally, blower-style cards are typically fitted with enclosed shrouds that exhaust hot air exclusively out the back of the case, which is said to further improve thermals of other components in the system, especially those of the small form factor variety. So today I am putting these various claims to the test to find out the optimal GPU configuration for this specific type of Mini ITX case. The first question in our investigation is whether a standard non-blower graphics card in an ATX case performs less adequately when put inside a small case where it's being encroached upon by the power supply. To test this as fairly as possible, I needed to build two systems using all the same parts, with the exception of the motherboard and, of course, the chassis. For our mid-tower, I decided on the Define S from Fractal Design, so it seemed appropriate to use their Define Nano S for our Mini ITX build, with its identical interior layout. The top moduvent covers were removed from both cases for more ventilation, and each system was equipped with a pair of Fractal's own GP series fans connected to the motherboard. All 140mm models except for the 120 exhaust in the Define Nano S due to mounting limitations. I'd also like to note here that the front intake fan in the Nano S was positioned to favor the GPU for all the tests we ran. Our processor is the Core i5-6600K that I've overclocked to 4.5 GHz, and that's with the help of Be Quiet's Dark Rock 3 cooler. Like our cases, I tried to find similar motherboards despite them having different form factors, so here we have the EVGA Z170 for the win and its tiny counterpart, the Z170 Stinger. The boards were paired with 8 gigs of Corsair LPX DDR4 at 3200 and powered by a Fractal Design Integra 750-watt PSU. Windows 10 and all applications were run from this 1TB Crucial MX200 SSD, and lastly for graphics we have the EVGA GTX 1070 for the Win Edition to represent our non-blower subject, and a GTX 1070 Founders Edition for our blower card. To better spot any thermal constraints, both GPUs were overclocked to the same core clock frequency of around 2 GHz, though we'll see that number vary a bit with different thermal conditions. I should also mention that I kept a close eye on ambient temps during today's test to ensure that my room never ventured outside the range of 25 to 26 degrees Celsius. To put a working load on the systems, I fired up Unigine Heaven 4.0 for 20 to 30 minutes at a time before taking a screenshot of all the temps, clock speeds, and other relevant data that we'll be using for comparison. With that said, let's circle back to answering our first question here, to see if our non-blower card favors one case or the other. Taking a look first at our mid-tower results in the Define S, our For the Win card was set to an auto fan curve and MSI Afterburner, averaging a core clock speed of 2025 MHz and maxing out at 80 degrees Celsius. Hopefully we don't see much hotter temps when switching cases, as this is already pretty toasty. On the bright side, the GPU clock speed maintained its 2025 MHz frequency despite the chip being relatively warm. For the CPU, the cores on our 6600K reached a max temp of 64 degrees Celsius, which seems about par for the course given this type of cooler and overclock. Now let's see how our Mini ITX system fared with the same OC and fan settings. CPU temps are pretty much the same. Maybe a degree warmer at most, but overall it seems moving to the smaller case hasn't had much effect on our cooler's ability to tame the CPU. Hopefully the same goes for our video Oh god, well, this is interesting. The GPU rose a whopping 5 degrees, taking it to a fiery 85 degrees Celsius. It also appears that this extra heat prompted GPU boost to enforce some thermal regulation, which brought down our core clock speed by about 25 MHz. Now the slightly lower frequency I can live with, but no GPU should be running at these temperatures for an extended period of time. From this initial test, we can conclude that a PSU restrictive chassis is likely to introduce more heat to a non-blower style video card. Would things improve if using a card with a blower fan, like our GTX 1070 Founders Edition here? Maybe. But first I wanted to see how much I'd have to crank the fans on our For the Win Edition to get us under the 80 degrees Celsius mark with the current OC settings. It turns out the answer was 95% fan speed. Only then did our GPU stay below 80 degrees Celsius under load, and my guess is that the fans are needing to work twice as hard because one of them is being starved for airflow by the power supply. A small benefit here is that the GPU boost actually bumped up the core clock to 2012 MHz due to the lower temperatures. Sure, we've escaped the thermal danger zone and even recovered some of our performance, but at what cost to our fragile ears? Here's a back-to-back sound test with the GPU fans at auto versus 95% sound speed. So, we have quite a predicament on our hands. In one scenario, we're suffering extremely hot GPU temperatures, and in another, we have an obnoxious amount of fan noise. Plus, having one of the GPU fans so close to the power supply doesn't do much to help our acoustics. And sure, this is why small form factor cases like the Define Nano S are geared towards liquid cooling over air. But still, there's bound to be some users who have either missed the memo or built a system similar to this one and find themselves in the same conundrum. If that sounds like you, and swapping parts out of your existing rig isn't an option, there's probably a few things you can do to remedy the issue, such as installing more case fans. The Nano S has some of the best fan mounting options for a chassis its size, tidying up the outgoing cables from your power supply to open up more airflow, or reducing or removing your GPU overclock entirely to keep it from overheating. Now, this might cost you some slight in-game performance, but it's likely not worth causing any damage to your components. I really wish I had time to test out the Nano S loaded up with case fans and such, but that's a focus for another video. Our next move here is to see if the GTX 1070 Founders Edition and its blower fan will be more effective in the Mini ITX chassis than our For the Win. So under load, we saw the GPU clock average out at the same 2 GHz mark with a max temp of 84 degrees Celsius. Interestingly, we found virtually no difference in performance or thermals between the two graphics cards in this setup. There was one change though. If we look over at our CPU temps, we can see that the 6600K actually dropped a whole 5 degrees Celsius on its hottest core. Could this be a fluke? Or was the enclosed shroud actually helping to move heat away from our CPU? To verify, I ran the load test once again, and what do you know, we came up with the same results. Our CPU temps seem to have improved significantly just by switching to the Founders Edition, but the card itself is still running pretty damn hot. So just as we did with the EVGA card, I tried to get the temps of our reference 1070 to stay below 80 degrees Celsius. To our delight, we easily reached our temperature target with only 60% fan speed. That seems a lot slower than the 95% that our For the Win card needed to operate at, but bear in mind that the fans we're comparing here are completely different in size and engineering, and if we look at GPU-Z, both cards were actually spinning at around the same RPM. So, which one do you think was quieter? Interesting. It turns out the Founders Edition ran much quieter under load. With its blower fan unimpeded, the cooler was able to operate as intended without requiring an absurd bump in fan speed, keeping noise levels down. The positioning also helped to eliminate any turbulence noise from the fan being pressed up against the power supply. The only benefit that our EVGA card saw in this test was a small 12 MHz boost in core clock speed, but I think most of us would prefer the dramatically reduced noise levels any day of the week. So to sum things up with today's results, to say that blower cards run inherently cooler than non-blower cards in this type of small form factor case doesn't always tell the full story. As per our testing, installing both cards and hitting the same clock speed resulted in identical temperatures. Where the blower card truly shines is its ability to operate at 100% efficiency, which allows it to maintain a quieter acoustic profile than a custom multi-fan card. Another bonus here is that an enclosed graphics card can make a significant dent in reducing temperatures of other components in a Mini ITX chassis. Both of these findings tend to make blower cards quite appealing to those building in a case like the Define Nano S, especially since a lot of add-in board partners are manufacturing these types of coolers at a reduced cost from their reference design counterparts. Of course, you can also beat the heat by using a card with an AIO liquid cooler, or go big with your own custom water cooling loop, assuming you have the funds. On a final note, I'd like to say that I'm not trying to throw shade to this new wave of mini cases, nor am I saying that the 1070 for the win is an awful card or anything like that. I'm simply sharing my data so that the DIY community can make informed buying decisions, and vendors can continue working to overcome these kinds of challenges in order to provide the best gaming desktop experience for all of us. If you guys want more info on all the parts that were used today, I'll put links in the description below. But that's gonna do it for now, guys, so let me know what you think about today's results, and feel free to share any of your own experiences in the comments with this kind of setup. Before you guys go, don't forget to toss me a like on this video if you enjoyed it, and also feel free to check out my store where you can pick up a shirt and possibly help support the channel. As always, thank you guys for watching, subscribe to the channel if you haven't already, and I will see you all in the next video.